occasionally rather than mathematically, and also a little bit about how to interpret what they mean. Probably the most important idea that I want to convey is that this is the right order of importance. If you measure something, the primary thing that I care about is the measurement that you made, the size of the effect. If that's all you tell me, that would probably be okay most of the time. Just tell me how big it is. My second question is going to be, how accurate is your measurement? Again, we're going to quantify the precision of the measurement, but I'm going to claim that this is a somewhat less important thing. And now a distant third important thing is to tell me whether the thing that you measured might actually be zero. And I'd like to have some notion of whether that might be true by chance or not. The problem that I see is that a lot of papers flip this around. So instead of effect size, most important thing, and p-value, distant third, what I often see is papers that have p-values in the abstract, as if it was the most important number, and no effect size in the whole paper. And I want to give you one example of this that drove me crazy a few years ago, but this is not the only example. I see this all the time. So you see things covered in newspapers and they say, look, there's this effect size. This was an example of math anxiety in elementary school. If your teacher has more math anxiety, it turns out that the students perform less well on exams. So that's interesting. That's a surprising result. It might be important,